find the general solution of the given system. So you're given the system, you're given the system in the form of x prime vector x prime. So here is your first you need to find a minus lambda I. So let's call this matrix is a matrix A, and you take this matrix minus lambda I, that gives you this matrix, and then you find the determinant of a minus lambda I, which is -6 minus lambda times 1 minus lambda minus 2 times -3. Okay, and then you distribute this out, simplify this, and then you will get this, set this equal to 0, and then solve for lambda. You will get lambda equals 0 and -5. So this is your eigenvalues, and for which eigenvalue you will get an eigenvector for it. So let's find those eigenvectors. When lambda equals 0, plug this into here. That gives you this matrix augmented with 0. Okay, right, after you augmented with 0, normally you would reduce this down to the base matrix, but I know that if you reduce it down to base matrix, you will get infinite solution. So instead of doing those matrices, I'm going to use this, either one of these equations, to solve for the unknowns. So I have negative, let's use the bottom equation. I have -3k1 plus k2 equals 0. That means that, so if I solve for k2, I got k2 equals 3k1. If I choose k1 equals 1, that gives me k2 equals 3. So you can choose whatever value for k1 or k2 and then solve for the other k. It doesn't matter, but I like to choose k1 equals 1 because 1 is a standard number. Do not use 0 because you will get a 0 matrix. Okay, all right, so you got k1, k2. Now the vector k is 1, 3. Right, so this is the eigenvector for lambda equals 0. Now you are going to do the same thing for lambda equals -5, plug it into here, and then you will get a new matrix, which is this, augmented with 0 again. You will get infinite solution if you reduce this down, if you solve for this matrix. So instead of reducing it down to a base matrix, I'm going to use either one of these matrices to solve for the unknowns. -1 k1 plus 2 k2 equals 0. So solve for k1, I got k1 equals 2 k2. Okay, it's kind of similar to this one, right? So now if I choose k2 equals 1, I got k1 equals 2. Then my vector k2 is 2, 1. Again, you can choose whatever value for k2 or k1 and solve for the other k. Okay, now here is your final solution. So because you have two distinct real eigenvalues, your final solution will be written in this form. Okay, so vector x equals c1 times k1. K1 is this 1, 3 times e to the lambda 1t. So vector k1 has lambda of 0. So you have e to 0t, which is 1. If you simplify it, plus c2 times vector k2, which is 2, 1, times e to the lambda 2t, and then lambda 2 is -5, so you have e to the -5t. Okay, so this is your final solution eventually. Don't forget to multiply by c1 and then c2, because that's part of, because your matrix because your matrices, this one depend on c1 and c2. This one could be something else. You can pull it out or take it out from this unknown constant. Okay, all right, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.